Eighth graders, we are on lesson 6.4, which is analyzing graphs. Really just kind of helping us understand, what do these graphs mean? What is happening when we see movement on the graphs? I think you'll find this, once you get a look at it, I think you'll find this makes sense pretty well. So graphs are representing something that is happening, and we have been focusing on a straight line scenario, but there's other types, so let's have a look. So in our Explore activity, we are given this graph. Looks all way different than what we've been looking at. And a story. A roller coaster park is open from May to October each year. May to October. The graph shows the number of park visitors over its season. So what we would want to do to interpret this graph is see what's happening. This is the amount of visitors. It's always good to orient yourself with what everything represents. This is the number of visitors. So this would be a low amount of visitors. This would be a high amount of visitors. And this is the time in months. They said from May to October. So we start in May. And it looks like we have some visitors, right? And then what happens here in the terms of visitors over time? Somewhere in June or July or something like that, we see a rise in visitors at the amusement park. Then in the third section here, it still rises a little bit, but it stays nice and high, even continues to go up a little, but not as rapidly as it did over here, the amount of visitors that started showing up. Then a sudden drop in the amount of visitors, and then even more of a drop in the amount of visitors over time. Doesn't say what the months are in each of these scenarios, but we can try and make a guess at what's going on based on what we know about a standard year and amusement parks. So segment 1 shows attendance during the opening weeks of the park season stayed constant. Stayed constant, meaning they had some visitors, not a lot, but it stayed that amount each day for that period of time. Describe what segment 2 shows. Well, what happens here? What happens in segment 2 compared to segment 1 where it was constant? You're right, it climbed up pretty rapidly too, right? Let's go ahead and record that. So I used the words attendance increased quickly. You may have worded it in a different way, but just as long as we all have the point across, the attendance rose, it went up. Based on the time frame, give a possible explanation for the change in attendance represented by segment 2. Why would it have risen so much? We have a roller coaster park. Let's think of the scenario. A roller coaster park that opened up in May. It had some attendance, and then suddenly, maybe around June-ish, it suddenly went up. What happens in a year between May and sometime in June where people are suddenly free to go to amusement parks? Right, school let out. So probably school let out right here. You have school letting out, and then you have lots of people going, and even still more people going. This is probably like June and July and even into August maybe. So based on the time frame, give a possible explanation for the change in attendance represented by segment 2. Probably school let out. So I worded that as summer vacation starts, or school let out for the summer, or however you worded it, same idea. Which segment of the graph shows decreasing attendance, where attendance goes down, and give a possible explanation? Well, decreasing with visitors going down is here and here, both 4 and 5. Give a possible explanation. Why do you think attendance went down so drastically there? Yeah, you're right, kind of along the same lines as summer vacation starting, and everybody has time to go to the amusement park. Now some school is back in session, and nobody has time to go to the amusement park anymore. So this one, we're going to say segment 4 and 5 show a decrease because school started back up. So the goal of this was simply to get us familiar with what is happening, what things can be happening. You always look at your labels to see what's going on, and then you can tell, oh, look, visitors went up, down, down. So it helps you understand a scenario that is happening. Let's look at some more. All right, this Explore activity gives us 3 scenarios: amounts of words learned and how long it took in 3 different ways. One goes up in a constant rate, one kind of slowly rises and then shoots up. Words learned here shoots up right away and then evens out over time. So you kind of get familiar with what's going on here. Then let's look at the story. Grace, Jet, and Mike are studying 100 words for a spelling bee. Grace started by learning how to spell many words each day, but then learned fewer and fewer words each day. Let's kind of circle pieces of information on that. Many words at first, but then fewer and fewer words each day. Okay. Probably already in your mind, after we already took a quick glance at the graphs, you might already be able to match which one is Grace, but let's look at Jet. Jet learned how to spell the same number of words each day. Jet was constant. He planned it out, and he learned how to spell the same number of words each day. Nice and constant, right? And you know that constant ends up in a straight line, so that's helpful. And finally, Mike started by learning how to spell the same number of words each day, so we should see some sort of a constant line, but then learned a greater number of words each day. So, same, we should see some sort of a straight line, but then it turns and a greater number of words each day. It starts to climb more rapidly. And what they want us to do is match which student matches which graph. So you can go ahead and try it, pause the video, try it, see what you get, and then let's see if we agree. Okay, so I see that Grace started learning how to spell many words each day. So she had a large increase, and then she slowed down and learned fewer and fewer. So then it kind of tapered off, and she was still learning them, but just much more slowly. Grace is graph C. Jet learned how to spell the same number of words each day. That's it, same number of words each day, constant. Words learned by time of day. It was very constant. That's very linear. Mike started to learn how to spell the same number of words each day, which we should see a line, and we do see a line here. But then he changed somewhere along the way and went a greater number of words each day. He must have thought, oh no, I'm not going to make it in time, and started really cramming in those spelling words, right? So we have Grace and Jet, a same number of words each day, and Mike started with the same number of words, realized, oh no, that's not going to be enough, and suddenly started cramming those spelling words to practice in, and increased dramatically after that. So that's all this wanted us to do. There's some questions for you to fill out on that, but it's helping you see what is happening in these scenarios in English in terms of shown in a graph scenario. Okay, let's look at Explore Activity 3. Mrs. Sutton provides free math tutoring to her students every day after school. How nice of her. No one comes to tutoring sessions during the first week of school. Poor Mrs. Sutton. Over the next 2 weeks, use of the tutoring service gradually increases. Let's circle a couple of key pieces of information. No one comes to tutoring the first week of school. No one. I'll change colors here. Over the next 2 weeks, there's a gradual increase. So they don't give us exact numbers, and that's okay. We just want to kind of plot out what that looks like in movement. So we would sketch a graph showing the number of students who use the tutoring service over the first 3 weeks of school. They want us to look at the 3 weeks of school. So we're only going to here. And what we do know is there were 0 students for the whole first week. So our graph isn't even starting until here. So we'll kind of draw a 0 there, 0 to the 1 week. And then a gradual increase for the next 2 weeks. So through week 2 and week 3, we saw a gradual increase. It could look like that. It might, maybe I made it too steep. Maybe it wasn't quite that much. I don't have exact data, so it doesn't have to be perfect. I just know it wasn't some sort of steep increase, right? Okay, so let's look at what happened next. Mrs. Sutton's students are told that they will have a math test at the end of the 5th week of school. How do you think this will affect the number of students who come to tutoring? Let's use that same graph here. If they have a test, all the students find out, oh, we have a test this day in the 5th week of school. What do you think is going to happen in the tutoring from here until week 5? Yeah, I agree with you. I think suddenly people are going to be like, I want to get an A on the test. I mean, assuming she has students who do want good grades. So she should see a pretty big increase over the next 2 weeks. Considering your answer to B, which was we would see an increase, sketch a graph showing the number of students who might use the tutoring service over the first 6 weeks of school. Okay, this extends past the 5th week of school where the test is at. We'll draw it back down here again, but after that 5th week of test, what are your thoughts on what will happen after the test is over? Yeah, I think I agree with you that there probably will be a decrease in people coming to tutoring. So let's graph it out. We know from week 0 to 1, there was nobody, a slow increase in the next 2 weeks. Then we said, hey, I think there's going to be a sudden increase because the test coming up. And then, yeah, we probably would see a decrease after the test. Maybe back down to the normal amount of students that she had. Something like that. And that's really it for this lesson. It's not about calculations. It's about reasoning out, what do we see happening? What does that graph in picture format look like when you reason it out into a scenario? That's all this is about. So if that felt comfortable to you, you should be in good shape. Use those reasoning skills and let me know if you need help.